Hi everyone! Welcome to my presentation about elements of XR prototyping, characterizing the role and use of prototypes in augmented and virtual reality design. I am Veronika Krauß and I am happy to guide you through a brief overview of our paper in which we highlight more professionalized practices around XR development to complement and add to existing work from XR tool research, interaction design research, and prototyping theory. We specifically look at the role prototypes play in industry development practices. With our work, we provide a conceptual perspective on XR prototyping rooted in both practices from industry and theoretical work in HCI research. Consequently, we reflect on the meaning, potential, and limitations of prototypes in XR design and based on that build a respective taxonomy. We conducted semi-structured interviews with 17 designers from XR industry using online video conferencing tools. This took place between February and May in 2021. In total, our 17 participants provided insights into 23 different projects. While some explained their approaches and prototypes in detail, others shared respective artifacts like videos or drawings or demonstrated their working prototypes via video feed. To analyze our rich dataset, we organized each interview individually on a virtual whiteboard. For each interview, we arranged images of provided prototypes and the verbal description. We then created process-like mind maps to visualize how the prototypes were used and evolved over time. By doing this, we ended up with 25 individual project maps. One of them is shown on this slide. With this as a basis, we set out to create our taxonomy. Our taxonomy builds on two concepts: manifestation of prototypes and the elements described by them. In total, our participants reported 8 different types of manifestations: sketches and drawings, diagrams and maps, text, video and images, digital assets, physical models, software, and ephemerals. Hereby, ephemerals are prototypes that do not possess a persistent form, such as acted-out system behavior. When investigating prototypes, we found that some features were more easily explained in specific manifestations. Those were therefore preferred by participants. For example, many of our participants sketched from a spectator's view to initially explain distances and dimensions. However, to experience those aspects, spatial features require manifestation as either digital or physical models in 3D space. In summary, XR prototypes demonstrate the need to describe ideas in space, time, and motion, often in the context of an imagined virtual environment, an existing physical environment, or a digital clone of the target real-world space. The use of physical models and especially ephemerals is prominent. As a second basis of our taxonomy, we identified the following 10 elements described by XR prototypes: spatiality, physicality, control, locomotion, flow story, flow hierarchy, interactivity, cinematography, world building, and content. Please refer to our paper to get a more detailed description. Typically, prototypes combined a subset of the 10 elements on differing levels of detail. This was depending on factors such as the designer's goal, time, skill, or the overall project requirements. For example, this picture shows how a participant imagined the interaction with an interactive app launcher. The most prominent element described is control, as the hand gesture hints towards both gesture control for selecting elements as well as how the gesture should be performed. Further, the element of spatiality is represented in a way that the prototype describes at which position this menu will appear. As you can see in the animation, also the element of interactivity is represented. Also, in Animate, XR prototypes combine several elements, such as presented in this trademark layout. On this slide, you can see an early version of a prototype for a VR experience room tour, enriched with both physical props as well as heat and wind for more central feedback. The tape marks depicted here describe the setup of the physical props in the target space to prototype the spatial layout of the final application. Therefore, this layout already incorporates the elements of spatiality and physicality. It further allows to experience how users will move through the space and therefore also depicts aspects of locomotion. Finally, as a summary of this presentation, I want to state and briefly answer our 3 research questions. First, what roles do prototypes play in industrial XR development practices? While we elicited many more reasons for roles, intentions, and prototype applications, we want to highlight that our participants reported to use prototypes to answer specific questions, such as how XR as a medium works and feels, what are the potential limitations of hardware and software, and how do specific features need to be realized. Furthermore, we learned that prototypes have at least 8 different types of manifestations, between which they might be transitioned to filter a design problem's complexity. Second, how do designers create and use XR prototypes? While the answer is indeed a bit more complex than creators use whatever helps and works, this is in fact a valid takeaway. Prototypes and their manifestations were a compromise of time, skill, design intent, target group, requirements, and tools. Since design tools still fail to produce, for example, accessible artifacts, our participants reported to often rely on acted-out system behavior or describing how a feature should look and feel like based on other already existing applications. Finally, third, where do prototypes reach their limits and what can we learn about designing supportive design tools? Our participants repeatedly reported that current tools fail to communicate the feeling of XR. While our paper hints towards several important aspects future design tool researchers and creators could tend to, one of the main takeaways is for sure that tools need to keep a prototype's context of use in case they aim at producing shareable artifacts. Further, tools need to allow repurposing, enriching, and adapting them and their content to provide a decent design support. With this, I reach the end of my presentation. Please refer to our paper for more detailed insights. Thank you for your attention and make sure to reach out to us if you want to discuss our ideas or insights in detail.